to the Electrical and Electronic Engineering Lecture Series. Your anchor person is Professor Michael C. Ndinechi. Our topic today is Module 043, Telecommunications Network Planning Standards. Please follow me in the engineering lecture series by subscribing to my YouTube channel at https://youtube.com/C. Please like, share, and drop your comments in the comment section or reach out to me using my email addresses. This lecture is a continuation of our lectures in telecommunication network planning and telecommunications network standards. You can listen to these two lectures using the two links given. You can also visit Ebony Educational Consult website at www.ebonyeducationalconsult.com for more engineering lectures. In this lecture, we will cover telecommunications network planning standards. The standards will be on numbering plans, transmission plans, charging plans, routing plan, signaling plan, grade of service, and design period for any telecommunication network. This lecture will signal the end of my lectures by topics on telecommunication networks. Introduction. Telecommunications network planning standards are those formal guidelines, rules, and technical specifications that engineers and planners follow when designing, developing, expanding, and/or upgrading an existing telecom network. It is a structured process of designing a network to meet specific service, coverage, capacity, and performance objectives. Planning standards define how this process should be carried out to ensure consistency, quality, and interoperability. These guidelines are set by international bodies like the ITU, the 3GPP, the national regulators like in Nigeria, NCC, NBC, or industry groups that guide how a telecommunications network should be designed, implemented, and maintained. The standards exist to make sure that the performance is reliable, that is, the calls, data, and services run smoothly without frequent failures. They exist to ensure that systems are compatible, that is, equipment from different vendors can work together, what is known as interoperability. They exist to ensure that quality of service is met. Quality of service means that customers get the expected speed, clarity, and uptime of the services provided for them. Again, about safety and security of the network. That is, networks are protected against hazards, cyber attacks, and misuse. And compliance with regulations, the guidelines also to ensure that the network meets local, national, and international laws. These standards ensure also that networks are efficient, that is optimal use of resources, reliable, that is minimal downtime and failures, interoperability, operable, which is ability to work with other networks and equipment, scalable, that is they can grow with future demands, and finally compliant, that is meeting legal and safety requirements. They are used during the planning phase of any telecom network to ensure that the design meets technical, regulatory, and operational benchmarks. Scope of planning standards. One is the network topology and architecture. This planning standard defines whether the network is going to be in the star, mesh, or hybrid topology form. The transmission standards will define the data rates, modulation schemes, and error correction schemes. You must also look at the quality of service metrics, that is the latency, jitter, packet loss, and throughput targets. When we talk of throughput, we talk of efficiency of the network. Let's talk about spectrum allocation and frequency planning, that is avoiding interferences and ensuring efficient usage. Also talk about safety standards, that is the electromagnetic exposure limits, grounding, and lightning protections. Must talk of also capacity planning, which means the forecasting demand and must ensure enough resources. Then let's talk about interconnection rules, that is ensuring networks can connect and exchange traffic seamlessly. Now, what are the importance of adhering to these standards? One is to ensure network reliability and uptime, to facilitate global connectivity without technical hitches, reduce maintenance costs by using standardized equipment, simplifies training for engineers and technicians, and enhances customer satisfaction through predictable service quality. Now, we look at them one by one. Now we have known what telecommunication planning standard mean. We are now looking at those plans that must be taken to standards. And the first thing there is the transmission plan. Now, say that a transmission plan is the engineering document and set of decisions that specify how traffic will be carried out between network sites, like between sites and sites, carried out at the point of presence, doing an internet, transmission, central offices, between sites and base stations. It is the physical and logical transport design, capacity, resilience, protection, and the equipment or technology choices needed to meet service, performance, and growth objectives. It is the overall network planning and translates traffic and topology requirements into links, wavelengths, fiber routes, microwave paths, and transport layer configurations. Core components of this transmission plan include topology and routing, that is, the physical routes, fiber ducts, microwave hub geometry, fiber splices, point of presence locations. Core component also is the capacity design that require interfaces, aggregation hierarchy, channel planning, wavelength counts, and grooming strategies. It also must take care of the link budget. By link budget, we mean that for fiber, you must talk about the attenuation, the connection stroke splice losses, margins, amplifier spacings for dense wavelength division multiplexing. If you are designing for microwave link, then the link budget must include the free space losses, antenna gains, rain and fading margins, Fresnel zone clearances, and licensing. If you follow me in my lectures by subscribing, you will get notification when we'll be looking at some of these things we have mentioned. For instance, when you talk of the Fresnel zone clearances, you are talking of, even though the transmitting antenna and the receiving antenna is said to be in line of sight, but there is a radius round the direct straight line that if you have any object within that radius, it will obstruct line of sight transmission. That radius, circular radius, is called the Fresnel zone clearance. Of course, we know about free space loss, and free space propagation, which is a function of distance from the transmitting point. And we know about fade margins. So, we cannot go into explaining all those things now because we are just talking about transmission plans. The next core component in this transmission plan is the transport technologies. So we start talking about, is it synchronous digital hierarchy you are going to use? Is it SONET, synchronous optical network? Or is it optical transport network? That is SDH, SONET, and OTN. Are you going to use MPLS, which is multi-protocol label switching transport protocol? Are you going to use carrier Ethernet, IP-MPLS, dense wave division multiplexing? Are you going to use microwave IP links? That is where you consider that in the transmission plan. You also talk about protection and resilience. That is, what topology are you going to use? Ring or mesh? What protections, these shared protection schemes or restoration procedures? What of service level agreement impacts? Then you talk about physical plans and standards. What cable specifications, what fiber type, what connectors type, what of external plant construction standards and testings. You also talk about network management and operations. That is how to monitor your network by setting certain monitoring alarms, performance counters, fault localization, and so on and so forth. You must also talk about regulatory and site constraints. For instance, you have rights of way. Where do you have permits to put your towers for microwave links and repeater stations? What about electromagnetic compatibility and spectrum coordination? These are things that come in the transmission plan. And finally, you look at the costs and phasing, because you will not do everything in one day. You must talk about phases. So you must talk about the capital expenditure and the operating expenditure after the network has been put in place. So you must do these estimates by also looking at the building and phasing plan and think of any fallback options, because if you have estimated your cost of acquiring equipment, and along the line there are price variations probably due to economic situations, and where do you fall back to get additional funding to complete your design or to complete your rollout. So you must all consider them during the transmission plans. So a quick checklist is you must collect inputs, that is traffic forecast, service level agreements, site coordinates, existing plant maps, regulatory constraints. You must look at the high level topology, that is, you choose the node locations and candidate routes. When we say candidate routes, for each of your transmission, which route you are going to take. And will it be using fiber or do that through wireless repeater stations? Talk of the capacity and technology fit. You have to decide the aggregation points. You have to look at what link you are using, say OTN, we say optical transport network. Are you going to use dense wavelength division multiplexing requirements? Are you going to use Ethernet or the multi-protocol layer switch, label switching layers? So, hope that you go back, look at some of these terms we are mentioning and know some more details about them. Like the MPLS, helps to give secure network when you are talking of internet systems. You must look at the link engineering. You compute link budgets like the optical power losses, the optical signal to noise ratio, amplifier spacings if you are using fiber optics, or if you are using microwave links, you must look at the path profiles, the fates you are going to meet. So, of course, you have to set some standard for, margins of all these things you compute or measure. Now, you also have to look at the survivability design. So you have to specify protection schemes per link and service class. Then you have to do a thorough site and civil works planning. For instance, what type of duct routing are you going to use? How are you going to pull the cables in case you are using duct? You have to pass the cable through them. Where do you set up the mast? What are the conditions that you've made to set up your mast or tower? Then, if you're using optical fibers, you must talk about the splice joints. Of course, you must also list the equipment and bill of materials which you are going to use for the network. So things like transponders, amplifiers, routers, switches, splitters for passive optical networks. Most look at antennas, power systems that can supply your base stations. So these are the equipment, and you must consider them. You must also look out for the operations, administration, and management of your design, and also consider testing plans. So in this case, you have to define the alarms, the acceptance test, the bit error rate, latency, jitter, OTDR. Then what are the acceptance criteria for some of these things? You must also consider phased rollout and risk mitigations. That is, you must consider staging, fallback lengths, and fall over testing. Now, you must do your documentation to meet standards. We say documentation and standards compliance, which you must make reference to, international bodies like the ITU, ETSI, TIA, and use their reference to do your local regulation paperwork. Now, the next plan you go into is the numbering plan. A numbering plan is a structured system used in telecommunications to assign telephone numbers, addressing codes, or other identifiers in a way that ensures unique identification of each user, efficient routing to each user, and compatibility across all networks. Because if you use your number, your equipment to make call to another person who is entirely in another network, so there must be a way to identify those other people in other networks. So the numbering plan must meet some certain standards, international standards. So these numbering plans are essential part of service design, interconnections, and international harmonizations. Generous allowance will be made for growth, catering for up to 50 years ahead. So, given numbering plans, you must project growth of the network for up to 50 years. The purpose of this numbering plan is for one, unique identification. That is, it must ensure every subscriber or service has a unique address. Two, it must have efficient routing system. That is, supports call and data packet routing without ambiguity. It must be scalable, so it must allow future expansion without reassigning numbers. It must be interoperable, so it must comply with international standards for cross-border communications. And of course, service differentiation. It must help separate fixed line, mobile lines, mobile systems, voice over internet protocol, emergencies, and special services. Now, types of numbering plans. The numbering plans could be closed numbering plan. That is, all telephone numbers have a fixed length. Two, open numbering plan. That is, telephone numbers can have or can vary in length. Then national numbering plan, which must be administered by the national regulator, NCC in Nigeria, for instance, and other countries have their own national regulators. Then you must be able to specify the country-specific formats, prefixes, and special codes, and must adhere to the International Numbering Plan as defined by ITUT Recommendation E164, which includes the country code, which is 1 to 3 digits, the national destination code, which identifies the operator service region, then the subscriber's number itself, which is unique user number. So for instance, we are conversant with the Nigerian model or mobile number system, which is +234, then the number. Say that the first 3 digits, which is 234, is the country code for Nigeria. Then you have the next 3 digits, 80, it could be 1, 3, it could be 81 something, but though that first 3 digits after the country code is the national destination code. That is for that particular mobile network. For instance, in Nigeria, we have MTN, Glo, Airtel, and 9 Mobile. So these 3 numbers, which is the national destination code, helps to identify which mobile network is using that, while as the last 7 digits is the special number for the subscriber. So in considering this network planning or number planning, so we say that when planning numbering within a telephone network, you must look at capacity forecasting. That is, you plan number blocks for growth in subscribers. You also talk of number portability, that is, which must support for users switching operators while keeping their numbers. If you recall, there was a time, there was number portability, promotion in Nigeria. So it doesn't matter which, network you are using, you retain your number when you migrate to another network. That is number portability. So you also talk of special numbers where you have short codes for emergency services. For instance, in some countries, they tell you to dial 911. When you do that, a particular service is provided. So we also have some special numbers when they tell you to call customer service, and you see that the number is very special. You also have government hotlines. So these are called special numbers. You must plan for them. We also talk about integration with voice over internet and other services, next generation numbering system. And here you must ensure numbering supports IP-based services because it's an emerging technology that continues to grow. We also talk of interconnection agreements. Your numbering plan must align with partner operators for seamless routing. Finally, you must talk about fraud protection. Your numbering system must be able to detect and prevent misuse of numbering resources. So, it's important at this point for us to note emerging trends so that we start looking at the future when we are doing numbering plan. So the first one is IP address integration. So we must note that in NGN, that is next generation networks, telephone numbers may map to IP addresses using e-numbering system, which is, E.164 number mapping, as stated in the ITU E164 system. There must be virtual numbering for over-the-top OTT, over-the-top and cloud telephone services. So when we talk about over-the-top, we are talking about, things like making use of, call it over-the-top videos. When you talk of YouTube videos, for instance, over-the-top services, over-the-top voice services, when you talk about, things like Skype and Zoom. So we call those services over-the-top videos, over-the-top videos. Talk of YouTube. For messaging, you talk about WhatsApp and Telegram. And for over-the-top voice, we talk about Zoom and other such services. So you must plan of how to be able to, number those services. And of course, we talk about machine-to-machine numbering, especially for Internet of Things devices, IoT devices. So at this point, we must note that a numbering plan is not just a list of numbers. It is a strategic design framework in telecom network, in general telecom network planning, that aligns with both national regulations and international standards to ensure scalability, interoperability, and efficient communications. Then we jump into charging plan. A charging plan, sometimes called tariff plan or pricing plan or charging scheme, is the operator's documented set of rules that specify how network use is measured, what is billed, when billing events are generated, and how charges are applied to customer accounts. How charges are applied. For instance, you have what you call pay as you go. Is also how, then you have some that, by, different ways charges are applied to customers. You have to determine it at the planning stage, how you charge your customers. So in standards and network planning, it covers both the business rules, that is the items to be, given tariff, called the tariff items, the bundles, the discounts, and the technical realizations, which you call the offline charging interfaces, CDRs, mediation billings. Because it is, sometimes you see some discounts. All these are built in during planning stage. If you fail to build them in, you may not be able to implement them when you have finished rolling out your network. So what are the objectives of a charging plan? One is revenue recovery and fairness. It's not just to recover revenue. You must seem to be fair to your customers. So that ensure services are built correctly so operator recovers costs and users are charged fairly. The next is regulatory compliance. So you must meet national and international tariff, taxation, and interconnect rules. Then service differentiation must enable quality of service-based, feature-based pricing. Example, video boost, peak to off-peak charges. Then, real-time control for prepay and fraud prevention. So this objective must allow balance checks, quota grants, and immediate blocking. Operational visibility and settlement must provide, CDRs. When we talk of CDRs, we are talking of call detail records. So you must, provide system of, getting to know the details of the calls. That is why it is possible if in case of, litigation, you'll be able to, recall and provide what transpired during that call. That is the CDRs, call detail records. And records for billing, roaming, settlements, and audits. For instance, when you roam your network into another country, there must be a way the local network and the one you are coming from, we have to settle bills. So it must be there during your charging plan design. So what are the typical tariff components? Your charge connection setup fee is a one-time fee. Subscription or rental, recurring monthly fee. You charge usage charges, that is some per minute, some per second, some per MB. If you are using data, per event, per message, session-based or volume-based. For instance, if you're using your Zoom, you set up your Zoom, they have a charge for, each session. So if you're browsing, you are charged per MB. So you must set up, your charges. If you're making calls, at times, it charge you per minute or per second. You must set them up. So allowances and bundles, which include minutes per data, rollover, family or shared plans. So these things are part of tariff plans. Some network will tell you, take a family plan where you load your credit, you share it with your family, and you have some level of discount. Also, you are using your mobile data, you buy for a month, for instance. They tell you that if you buy another one before the end of the month, whatever data you have not used will be rolled over to the next month. So all these are plans designed during the charge planning time, or else you will not be able to implement them. You also look at the time, location, quality of service modifiers. For instance, in every telecommunication system, you have the peak time, you have the off-peak, have the on-net or off-net, then priority services. For instance, some network will tell you if you make calls between 11 midnight and 1 a.m. the following day, that your charge is going to be 50% of what it's supposed to be. So you see that that time is off peak, but they want people to make use of that. So they give some kind of rebate for people making calls during that time. This has to be done automatically, so it has to be built in during the charging plan design. So he also talks of things like promotions, discounts, taxes, and so charges. These are all components of tariff. Then, what of the routing plan? Say in telecommunication network planning, a routing plan is a structured set of rules and configurations that determine how calls, data packets, or messages are directed from one point in the network to another. It ensures efficient, reliable, and cost-effective use of network resources while still meeting quality of service and regulatory standards. What are the purposes of routing plan? Say that a well-designed routing plan aims to ensure connectivity between all network nodes and external networks, aims to optimize network resources by balancing tariff on traffic load and minimizing congestions, ensures to maintain service quality. Service quality, we are looking at low latency, minimal packet losses for internet-based or data-based services, high call completion rates, and so on and so forth. It aims to provide redundancy, that is, alternate paths in case of failure, and aims to comply with international regulations and other regulations, that is, emergency call routing, lawful interceptions, numbering plans, and so on and so forth. Because sometimes, it may be lawful for, law enforcement agents to intercept your calls. So routing plan enables them to do that. So key elements in a routing plan include routing architecture. That is it going to be hierarchical, where you use a layer structure like in the plain old telephone system or public switch telephones, network, PSTN? You have your local, from local to regional, from regional to national, from national to international. So you say that it is hierarchical, starting at the lower base, the local exchange. You move up the ladder to regional exchange. Another to the ladder is the national exchange. And from there, you have the international gateway, where your calls can now escape your territorial boundary. So you also have what is known as the flat routing, which in case means direct routes between all nodes. And this is common in smaller IP-based networks. Then another key element in routing plan is the traffic types considered. We have the voice calls for public switch telephone networks, voice over internet protocol. We have data packet, which is the internet traffic. You have the signaling, messages, the SS7, the SIP. SIP means session initiation protocol, the signal 7-segment signaling, the SIP session initiation protocol, mainly for internet systems where you have video, voice, and data in a particular, session. So the SIP helps you to start and to terminate that session. We also have the multimedia streams. So again, you have routing tables and policies for your internet-based systems. You have your IP routing tables. It could be in form of IP version 4 or Internet Protocol version 6 for packet networks. Then you also have time of the day or least cost routing for voice networks, quality-based routing, that is choosing the path with lowest latency and jitter. You also have the primary and alternate routes. For primary routing, the default paths under normal conditions are used. For alternate routes, you now have backup paths used during congestions or failures. In communications, you talk about the alternate path as hot standby. So you also have your numbering and addressing standards. We've said that ITU E164 sets some of these standards. For IP addressing, you have to follow the IETF and RFC guidelines. Then we talk of the signaling plans. In telecommunications network planning, signaling standard plans are strategic frameworks that define how network components communicate, control, and manage information to set up, manage, and release connections. It is important for you to note what signaling means and how it is planned in telecommunications. They are essential because voice, data, and multimedia services all depend on standardized signaling to interconnect seamlessly across different operators, equipment vendors, and technologies. If you make your design that doesn't follow standards, then you will not be able, your design or your network will not be able to connect and communicate with some other networks. What are the purposes of signaling standard plans? A signaling standard plan in telecom network planning ensures one, interoperability between networks, that is national and international, to ensure compatibility with existing and future technologies, to ensure efficient call setup and release, must support for multiple services like voice, SMS, internet, and other multimedia services. It must comply with regulatory compliance with ITUT, ETSI, 3GPP, or other national standards. Now, what are the types of signaling plan? Network planners typically consider these main signaling types. First one is the channel associated signal, known as CAS. So signaling here occurs within the same channel as the user's communication. The other one is the CCS, which is the common channel signaling. Here, a separate channel is dedicated for control signals. Example, in the signal system number 7, SS7, in fixed and mobile networks, and for faster, more secure, complex services, you make use of common channel signaling. So when you are planning signaling standards, there are basic things you must consider, and they must include, must assess the traffic forecast by estimating the signaling load from call attempts, handovers for mobile devices, then SMS, Internet of Things devices, and so on and so forth. You must select appropriate protocols. You must match protocol to service type. Example, we have talked about session initiation protocol for voice over internet protocols. What do we have? Voice over internet protocols, where you have your voice, data, and messages sent across internet at the same time. So you use SIP signaling. Then you have diameter signaling for long-time evolution devices, LTE. Then you must plan for redundancy. By that, we mean that you must avoid single points of failure. So you must use multiple signaling transfer points, STPs, so that if one fails, the other one will remain, or else you will not be able to stop what is going on. So when one fails, the other one, because the signaling, systems help you to establish and to terminate communication between two devices. So again, you must think of interconnect strategy. By this, you must define gateways for inter-operator and international signaling. You also must talk about the migration part. You have to ensure smooth evolution from legacy to next generation signaling. Something from moving from, SS7 to SIGTRAN to SIP for 5G protocols. So you must think of, migrating from one signaling system to the other. Of course, you must talk about security. You must protect signaling from threats like SS7 attacks, SIP hijacking, diameter flooding for LTEs. Now, we jump into the next, which is very important aspect of telecommunication network planning standards, and that is grade of service. In telecommunication network planning standards, the grade of service, always noted as GOS, is a quantitative measure of the quality of service a network offers to its users, specifically in terms of call handling capability during busy traffic periods. It is very important. In most cases, people do not understand exactly what grade of service is. And we will draw an analogy here to make sure that you always remember and know what grade of service is as a telecommunications student or a telecoms engineer. This grade of service is defined as the probability that a call or service request will be blocked or delayed beyond an acceptable limit due to insufficient network resources like circuits, channels, or bandwidth. Now, what are the key things you consider in grade of service? First, grade of service is usually expressed as a decimal or percentage. For instance, if you are told that grade of service is equal to 0.01, it means that 1% of calls are blocked during the busiest hour. If you are told that grade of service is equal to 0.002, it means that you have two blocked calls per 1,000 attempts in the peak hour. Now, the basic things you will note is that grade of service is measured during the busy hour. That is, that 60-minute period with the highest traffic load in a day. This ensures the network is designed to handle peak demand without excessive blocking. Now, this grade of service has some standards and recommendations set out for them. First, ITU-T has set telecommunications standard sector specify GOS, that is grade of service targets, depending on the service type. For the traditional public switch telephone network, voice networks, it's stated that is 1 to 2% call blocking during the busy hour. For mobile networks, it says it should be less than or equal to 2% call blocking for voice, but stricter for data sessions. For mission critical services, the grade of service has to be less than 0.5%. Now, having been, teaching some communication topics for a long time, it's been somehow difficult to, explain this grade of service in ordinary terms to a layperson, but we have to try it here now. Grade of service is like a restaurant ability to seat customers during the rush hour. Just imagine a restaurant owner and sited in a high business area, and between 1 o'clock in the afternoon and 2 o'clock, the companies around are on break, and many people have to flock into the restaurant to eat. Now, will the restaurant owner provide seats to make sure that everybody that entered the restaurant will be able to get a seat during that rush hour? Or will he provide seats enough and allow people that couldn't get seated at that time to find another place? We use it to illustrate this grade of service. So, a low grade of service means almost everyone gets a table right away immediately he enters that restaurant. If you provide enough for everybody during that rush hour, you say you have low grade of service. A high grade of service means many people are told to wait or leave. So the number of people that are not taken care of during that busy hour determines the grade of service of that restaurant. You can link it to the bank. Maybe on Mondays, there are so many people in the bank wanting to withdraw money or to transact business. As the week thins out to Friday, the number reduces. So the number of people the bank is not able to cater for on Mondays because of the rush means the grade of service for that bank. So with this, I believe that my listeners will really understand what grade of service means in telecoms. That is the number of people that are not taken care of during the rush hour is used to rate the grade of service of that telecoms. So this grade of service is, calculated somehow in circuit switch networks. Grade of service is calculated using ELANC. ELANC is denoted by P, or what is known as ELANC formulas, based on traffic offered in ELANCs, number of circuits or channels, whereas in packet switch networks, it can be related to packet loss probability or latency thresholds. Example again, if in a busy hour, 1,000 calls are attempted and 10 calls are blocked because all circuits are busy, then we say that the grade of service can be calculated as total attempts 10 out of 1,000, which is 0.01 or 1%. So that becomes your grade of service. Why does this grade of service matter in network planning? One, it ensures a balance between cost and quality. Remember, if you provide, in the case of the restaurant we use, if you provide all seats so that everybody in that rush hour gets seated, your cost will be high. Then what happens when the rush hour dies down? Those seats will remain idle. But then, if you don't provide enough, the quality of what you provide will not be there because people will get disenchanted coming to your restaurant because the probability of them not getting seats is high. So it's a trade-off between the cost you are to handle and the quality of service you want to provide. So say low grade of service value means fewer blocked calls, which requires more network resources, translates to higher cost. High grade of services means cheaper network, but poorer user experience. The users will not be very happy when you have high grade of service value. So this grade of service is used to decide how many channels or circuits to install, how much bandwidth to allocate, when to upgrade or expand network capacity. Finally, we quickly look at design period for telecommunication network. So in telecommunication network planning standards, the design period refers to the time horizon over which a network is expected to meet its intended service requirements without major redesign. So think of it as the planning lifetime of the network configuration and capacity before it will need significant expansion. Key points in the design period include one definition. It is the number of years into the future for which the network is planned during the initial design phase. For example, a telecom network might be planned for a design period of 5, 10, 15, or 25 years, depending on the standard or project scope. The purpose is to ensure that the network can handle forecasted traffic demand throughout its lifespan, helps in cost optimization, avoiding frequent redesigns, and must align with national or international telecom planning guidelines, more especially as those recommended by the ITUT. Factors affecting design periods selection, you have to talk of the technology life cycle. Because of faster technology evolution often means shorter design periods. Because if you design for 25 years and within that 25 years, there's a lot of, technology evolutions, then you may not meet up. So that gets you to make not too long, life cycle. Then capital investment scale. Large infrastructure like optical backbone networks may have longer design periods, 10 to 15 years. Then demand growth rate, you know that this factor will affect you. So higher growth rates may require shorter design horizons to stay adaptable. Then regulatory or policy frameworks. So standards may set minimum, maximum design horizon. So it's good to look at also international standards too. Also related to forecasting. The design period is directly linked to traffic forecasting. Planners calculate future demand at the end of the design period and ensure network capacity topology and quality of service targets can meet that demand. So we conclude this work by saying that telecommunication network planning standards act as the rule book for building networks that are safe, efficient, and compatible across the globe. In an industry that thrives on connectivity, adherence to standards is not optional. It's the foundation of a functional and sustainable network. Thank you for listening. Thank you for your patience in following these long lectures. Just, I'm not very conducive to break it up into different lectures.